Flight 9 nears liftoff, Dragon CRS-32 delivers breakthroughs, and China-Russia's lunar power plant fuels cosmic rivalry. Can SpaceX lead the race? Join Starship mission updates. Let's dive into the stars. We're now just hours away from the highly anticipated Flight 9, and final preparations are in full swing. As mentioned in the previous episode, the road closure schedule had been announced for May 24th through the 26th, and right on cue, the action began. Following the unexpected early rollout last week, B-14 completed its check and corrective work inside Mega Bay 1. By noon on the 24th, the large bay doors were opened, and B-14 was carefully rolled out. Observers quickly noticed a key detail. The hot staging ring appeared to have been realigned, a sign that recent issues had been addressed. Later that evening, exactly within the road closure window, B-14 was transported to the launch pad. In anticipation of its arrival, the chopstick arms had already been raised, and the ship quick disconnect arm was repositioned. Clear signs the pad was being readied for staging. By the morning of the 25th, B-14 was successfully lifted onto the orbital launch mount, taking its place in the launch setup. Attention then shifted to S-35. After finishing a spin prime test at the Marseille test site, S-35 returned to Mega Bay 2 for final preparations. Late on the 23rd and into the early hours of the 24th, the PEZ door was opened, and by that afternoon, the Starlink simulators, also known as dumb links, were loaded into its payload section. This final step was confirmed when the payload door was sealed shut by the morning of the 25th. With the payload secured and all systems go, S-35 was moved to the launch pad on the afternoon of May 25th. That evening, the stacking process was completed as S-35 was lifted and installed atop B-14, forming the full Starship Flight 9 stack. This moment marked the final major hardware milestone before liftoff. With stacking now complete, SpaceX will observe a short holiday pause. All activities will temporarily halt, with work expected to resume the morning of the 27th in preparation for the scheduled launch that afternoon. As it stands, the current launch target is 6:30 p.m. Central on May 27th. However, the approved road closure window extends through the 29th, offering flexibility in the event of delays. Fingers crossed that things stay on track. That said, there's one important point we can't ignore. Will SpaceX conduct a wet dress rehearsal for Flight 9? This crucial test was skipped ahead of Flight 8, which led to an aborted first launch attempt and ultimately more technical issues during the next flight. Many fans, myself included, believe a WDR is essential this time around. Given that the morning of the 27th remains open before the scheduled liftoff window, SpaceX does have the time to conduct a WDR. Yes, it takes additional effort and coordination, but the payoff in reliability and mission confidence could be huge. If problems are detected, there's still a short window to make adjustments before launch. In the end, what we all want is a successful flight, and that extra step may be exactly what ensures it. Let's hope SpaceX takes the cautious route this time. So as we head into the holiday break, I hope you enjoy some well-earned rest with family and friends. And when activities resume, we'll be back in full swing with another exciting Starship launch on the horizon. Turning to the Dragon CRS-32 mission, SpaceX notched another major success. After undocking from the International Space Station on the 23rd, Dragon spent a day in orbit before re-entering Earth's atmosphere. At 1:46 in the morning Eastern Time, or 10:46 p.m. Pacific, the spacecraft splashed down safely off Southern California, completing a flawless return. All key milestones, deorbit burn, trunk jettison, and parachute deployment, went smoothly. What makes CRS-32 particularly significant are the new recovery innovations. For the first time since the FRAM-2 mission, SpaceX opted for a Pacific Ocean splashdown, a strategic shift to minimize risks from space debris, especially related to trunk jettisoning. This reflects a more careful and environmentally aware approach to recovery. Even more groundbreaking was the use of in-house drogue parachutes. SpaceX confirmed that CRS-32 was the first mission to feature drogues designed and manufactured entirely in-house. According to the company, these parachutes include data-driven upgrades such as stronger joints, improved ribbons, and a redesigned pack for better deployment and inflation. This move towards vertical integration enhances reliability and gives SpaceX greater control over mission-critical components. With the successful return of CRS-32, SpaceX continues to set the bar for orbital logistics. This mission marked the 32nd official cargo flight and the 49th overall Dragon mission, encompassing both crewed and uncrewed operations. It's a testament to the Dragon program's enduring performance and adaptability. Looking ahead, these upgrades signal promising advancements in Dragon's future roles. From advanced recovery to tighter manufacturing control, SpaceX is paving the way for broader applications, supporting commercial space stations, lunar logistics, and evolving human spaceflight. Beyond the excitement surrounding Flight 9, Starbase is buzzing with several pivotal developments that could reshape the future of SpaceX. One of the most highly anticipated events is the upcoming company talk, scheduled just before the Flight 9 launch. Multiple sources indicate this special presentation will take place on the 27th, just hours before liftoff, likely between the late morning and early afternoon. Set at the production site, the event is expected to last 1 to 2 hours and is titled Mars 2026 Company Talk. This title alone signals a strong focus on SpaceX's interplanetary goals, particularly plans for reaching Mars. Elon Musk is expected to headline the talk, marking a return to SpaceX leadership after a period of public focus on other matters. In addition to Mars plans, Musk may also address Flight 9, upcoming missions, strategic 2025 goals, and possibly unveil new rocket systems or internal projects. This event is more than a routine update. It's a potential turning point for SpaceX, one that could reinvigorate internal morale and sharpen the company's vision heading into the next phase of Starship development. Meanwhile, another major change is happening at the production site, the dismantling of the iconic high bay. As of May 24th, the final structural frames of the high bay were removed, marking the end of an era. These parts are now being cleared away to make room for Gigabay, a massive new facility designed to meet the growing demands of Starship production. Construction is expected to take about 6 months, putting Gigabay on track to be operational by late 2025 or early 2026. This new facility will significantly expand SpaceX's capabilities, ushering in the next generation of Starship hardware. High Bay has been instrumental in the early development of Starship, serving as a site for stacking, refurbishing, and inspections. However, as SpaceX ramps up production and integrates more complex systems like Starship V3, the limitations of the High Bay have become clear. The transition to Gigabay reflects SpaceX's move into a high-volume, production-heavy phase. Already, the first Super Heavy V3 booster is being stacked inside Megabay 1, while S-39, the first V3 class ship, is expected to follow soon in Megabay 2. Once Gigabay is complete, it will likely take over major assembly and integration tasks, firmly establishing the V3 era of Starship. In parallel, preparations continue for upcoming flights. A road closure is scheduled for May 28th, from midnight to 4 a.m., to facilitate the transport of hardware from the factory to the Massey test site. This likely involves S-37, a newly completed prototype that will pair with B-17 for Flight 11. B-17 has already passed cryogenic testing and is currently housed at the Rocket Garden. All of this underscores SpaceX's relentless momentum. While Flight 9 captures public attention, these behind-the-scenes developments are equally critical to the broader mission. Now let's shift our focus to an ambitious and somewhat startling development: China and Russia's joint plan to build a nuclear-powered energy plant on the moon. In a bold move that underscores their growing collaboration in space, China and Russia have officially signed a memorandum of cooperation to develop a lunar power reactor. This facility will supply energy to the International Lunar Research Station, ILRS, a large-scale moon-based project spearheaded by both nations. According to the agreement, the reactor is slated for completion by 2036, and its purpose will be to power long-term operations on the lunar surface. This announcement came at an interesting time, just days after NASA unveiled its 2026 budget proposal, which notably includes cutting back plans for an orbital lunar base. The contrast between expanding ambitions on one side and scaling back on the other couldn't be more striking. What makes the Chinese-Russian plan even more fascinating is that the lunar reactor is expected to be constructed autonomously without human presence on the moon during its assembly. In a 2024 interview, Yuri Borisov, the Director General of Roscosmos, stated that the technical capabilities to achieve this are almost ready, although specific details on how this will be accomplished remain unclear. Still, it suggests a major leap in autonomous robotic construction technologies in extreme environments. On the 8th of May, Roscosmos issued a statement explaining that the ILRS will conduct fundamental space research and test technology for long-term uncrewed operations, with the prospect of human presence on the moon. The ILRS is envisioned as a permanent manned base located near the moon's south pole, an area believed to be rich in water ice, making it a strategic site for future human exploration. 17 countries have reportedly joined the ILRS program so far. The project's construction will begin with China's Chang'e 8 mission, scheduled for 2028. This mission will lay the foundation for China's first crewed lunar landing, marking a historic milestone in their lunar ambitions. The roadmap for the ILRS was first presented in June of 2021 and outlines an aggressive launch schedule from 2030 to 2035. During this period, China and Russia plan to deploy 5 super heavy lift rockets to transport essential infrastructure to the moon. These components will eventually be linked together, forming a base that connects to an orbiting lunar station and surface nodes at both the moon's equator and far side. By 2050, the entire lunar infrastructure is expected to be fully operational, potentially serving as a launch pad for manned Mars missions. Wu Yanhua, chief designer of China's deep space exploration program, noted that the system will be powered by a combination of solar panels, radioisotope thermoelectric generators, and nuclear energy. The station will also support advanced communication networks, autonomous rovers, pressurized and unpressurized vehicles, and even a hopper designed for long-distance surface travel. While China and Russia push forward with this futuristic vision, NASA's Artemis program is struggling with delays and tightening budgets. As America reassesses its roadmap, the global space race is clearly shifting. The moon is becoming more crowded and more competitive than ever before. All eyes are now on how NASA and its partners will respond to these bold new moves. This is your mission update team with Starship mission updates. From Flight 9's countdown to lunar power plants, the space race ignites. Like, subscribe, and keep looking up. Can SpaceX outshine the lunar race? Share your predictions below.